Hi, I'm back. My name is Erwin Rama, and today we'll be having a video lecture about the summary of 3 laws of thermodynamics. But do you really understand the definition of the 3 laws of thermodynamics as easy as possible?
The summary of the 3 laws of thermodynamics. Before we proceed to the lesson, we need to define first, what is thermodynamics?
According to Britannica, thermodynamics is a science of the relationship between heat, work, temperature, and energy. In broad terms, thermodynamics deals with the transfer of energy from one place to another and from one form to another. The key concept is that heat is a form of energy corresponding to a definite amount of mechanical work. So the first thing we would like to mention is the definition of the 3 laws, some examples, and differences to get everybody what actually the 3 laws of thermodynamics. For those who don't know the first law of thermodynamics, I would like to introduce to you Ms. Micaela Nicole Torrejos, who will explain the summary of first law.
First law of thermodynamics shown are 2 examples being transferred from one system to another and transformed from one form to another. The transfer and transformation of energy takes place around us all the time. The law states that the total amount of energy is constant. In other words, there has always will be exactly the same amount of energy in the universe. It is an version of the law of conservation of energy. Energy can be neither created nor destroyed.
To give you more information, we'll give an example based on the experiment. So for example, expanding the balloon using hot water. So the materials we use is plastic bottle, basin, balloon, and hot water. So first, attach the balloon at the top of the bottle and then put it in the basin and put some hot water. So as we observe, as we put the hot water in the basin, the balloon keeps expanding, and it explains the first law of thermodynamics. But here's the question. How does it relate to the first law of thermodynamics? And how does it happen? So to answer that, first law of thermodynamics involves internal energy, heat, and work, which is represented as U internal energy is equal to Q heat minus W work. In the experiment, balloon expand as we add the hot water, in which heat transfer from the surrounding to the system. So Q or heat is positive because the hot water is higher than the air inside the balloon, and the W or work is negative because the work is done by the system. The heat input is stored inside the system as internal energy before it transforms to work. So that's how it applies the first law of thermodynamics.
So for now, let's move on to the second law of thermodynamics. Second law of thermodynamics states that the total entropy can never decrease over time for an isolated system, a system in which neither energy nor matter can enter nor leave. In other words, second law states that the entropy of any isolated system always increases. To get everybody of us, how does second law works? Miss Camila Abdul will explain to you the example based on an experiment.
For example, balloon in candle flame. The materials is candle with flame, balloon, and a water. So first trial without any water. So first, blow the balloon and light up the candle, and place the balloon on the top of a candle flame. As you can see, the balloon explodes. And the second trial with some water. What happened if you put some water inside the balloon? As you can see, the balloon didn't explode. And this is how it works on the second law of thermodynamics. But the question, how does it work and how does it happen? Let me explain. When we place the balloon on the flame, the energy is transferred from candle to the balloon in the form of heat. Heat flow will generate entropy in which percent Q is equal to Ts. For the first trial, the heat from the candle is transferred to the air inside the balloon. This caused the air to expand and the balloon burst with a few seconds. For the second trial, the heat is transferred to the water as it is a great conductor of heat. The water closest to the flame heats up and it begins to rise. Cooler water observe more heat process repeat due to the conversion process. The balloon does not burst, in which UT may take a longer time to burst, and that's how it applies to the concept of second law of thermodynamics.
We have worked with the first and second law of thermodynamics. And we will now let's proceed to the summary of the third law of thermodynamics. Third law of thermodynamics states that the entropy of a perfect crystal of a pure substance approaches zero as the temperature approaches zero. The alignment of a perfect crystal leaves no ambiguity as the location and orientation of each part of the crystal. To give more information, Mr. Bicoy will give an example about this third law.
For example, mercury is the only metal that liquid at room temperature and pressure. It doesn't become a solid until it goes below negative 38 degrees Celsius. It's a best example for third law of thermodynamics because when its liquid molecules are freely move but when temperature decreases, the molecules will settle down and complete stack makes it solid. When mercury atoms in the liquid have enough thermal energy, they can break fall from the surface in the form of vapor. This vapor has higher entropy states, meaning there are more ways in which the atoms can arrange themselves in the space around them. The less energy there is a substance, the more ordered the atoms are within it.
Let's move on to the difference between first, second, third law of thermodynamics. First law of thermodynamics is related to conservation energy, while the second law of thermodynamics argues that some of the thermodynamics process are impermissible and does not entirely follow the first law of thermodynamics. The third law of thermodynamics says that a perfect crystalline structure at absolute zero temperature will have a zero disorder or entropy.
Another differences between these three laws. First thing first is the differences between these three laws. The first law of thermodynamics is about the law of conservation of energy. It cannot be created or destroyed. In other words, energy can be converted from one form to another. Second law of thermodynamics is about the process that involve the transfer or conversion of heat are irreversible, in which the second law of thermodynamics defined as heat cannot flow itself from colder body to hotter body. Third law of thermodynamics defines the sign of the entropy of any substances at any temperature, above the absolute zero as positive. And it provides a fixed reference point that allows us to measure the absolute entropy of any substance at any temperature.
Now, let's move on to the similarities between these three laws of thermodynamics. The similarities of these three laws is they are all unique
with the transfer of energy from one place to another and one form to another, in which thermodynamics was means is to deal with conversions from heat energy into mechanical vice versa. That's all. We hope that you all understand what actually means the three laws of thermodynamics. Here's a question and answer for this video. Differentiate the concept of each law of thermodynamics. Comment below your thoughts and answer. Thank you and have a nice day. Bye!